It should be possible to write rules in your choice of scripting languages. The rules we review in this course are written in the iRODS rule language. Zhu has created a pluggable rule engine that supports multiple scripting languages. The pluggable rule engine will be available in iRODS version 4.2. 4 languages are supported, including the original iRODS rule language syntax prior to iRODS version 3.0, the current iRODS rule language syntax, Python scripts, and Java scripts. It is possible to write rule functions in any of the languages and invoke the rule functions within your rule. Thus, you can write a rule that invokes Python scripts or Java scripts or iRODS language rule functions. A demonstration of the technology showed a rule written in the iRODS rule language that invoked a rule function written in a Python script. The Python script invoked a rule function written in JavaScript, and the JavaScript invoked a rule function written in the iRODS rule language. This establishes rule language interoperability across scripting languages. The rule engine was modified to support language plugins. Each plugin controlled 5 basic operations and took about 100 lines of code to implement. The operations were start execution of a rule function, stop execution of a rule function, verify that a rule function exists, execute a rule function, provide a callback from the rule plugin to the iRODS data grid. The different scripting languages could invoke iRODS microservices and could query the persistent state information. The person writing the rules still needed to know which microservice supported an operation and which persistent state attributes contained the information required for execution of the operation. A description of the pluggable rule engine is available at irods.org, zoo pluggableruleengine.pdf. An example of the execution of a Python script from the iRODS rule language is shown here. The rule is loaded into the rule base to control what is done each time a file is loaded into the data grid. At the AC postproc for put policy enforcement point, a delayed execution is invoked of a Python script that is located on a remote resource called computing resource. The system accesses the remote resource, then executes the named Python script, which calls an iRODS microservice to write a line to a server log. The rule is queued but executed immediately. The delay was set to 0 seconds. The host where the Python script is executed is accessed by the remote microservice. The rule functions within the braces following the remote command are packaged for execution at the remote site. The location of the object is defined by the session variable $objpath. The Python script uses this as an input parameter and specifies that the parameter comes from a rule written in the iRODS language. The WriteLine microservice is also annotated as an iRODS rule language function. The output is written to the server log, since output to the user's laptop screen is no longer possible when the rule is queued for execution. The user session will have terminated before the Python script is executed. Take 7 minutes to complete exercise 38. Identify the policy enforcement points that should be monitored for the event you selected to audit. See Appendix B of the Policy Examples Workbook. More than one policy enforcement point may need to be monitored for the selected event. Please load your paragraph into the Lifetime Library in the sub-collection class INLS 624 by the end of today's class.